All right, volatile solids reduction. When I took my grade 2, they didn't give you this formula, but when I recently just took my grade 3, all of a sudden it was on the cheat sheet. So I'm not sure if that was a temporary thing that they did or if this is permanent from now on, but when I took this test, I had to memorize the formula. And it's kind of a tricky formula to memorize. And a volatile solids reduction is how much percent are you reducing the volatile matter? So how much organic matter are your anaerobic bugs consuming and turning into gas in your digester? So the formula is what's coming in minus what's coming out over what's coming in minus what's going in times what's coming out times 100. Now the important thing to note is parentheses. Anytime you have parentheses, you have to do what's in the parentheses first. So I need to multiply in times out before I subtract it from the in, or else I'm going to get the answer wrong. And another thing that's important to note is you have to convert these percentages to a number. Now remember, 1 is 100%. So if I have 85% or 70%, it's point whatever. So 0.85 and 0.7. So let's figure out the top part, in minus out. So I have in raw sludge Vs of 85%, so 0.85, minus out digested sludge Vs 70%. So 0.85 minus 0.7 equals 0.15. So that's the top part, in minus out. Now let's do in times out. 0.85 times 0.7 equals 0.595. So that's in times out. So in minus in times out, 0.85 minus 0.595 equals 0.255. So I've discovered in minus out, and these two I've discovered in minus in times out. So if I throw these together, 0.15 in minus out divided by 0.255 in minus the in times the out times 100 should give me a volatile solids reduction of 59%. And when you're studying for your grade 3, you'll soon learn what this number means and what's a good number, what's a bad number. And this is actually probably a too good to be true number. Usually volatile solids reduction is between 40 and 60%. So if you got a 59%, your digesters are kicking it. And they're kicking it good. So let's go on. All right, flow. This is kind of one of the trickier problems because it involves conversions from what they give you into something that's kind of completely out there. Because they do give you the formula for flow on the exam. I think it's flow equals, or a velocity equals area divided by flow. But that's all they give you. They don't give you units, and it's really velocity, feet per second, divided by area, feet squared, over flow, cubic feet per second. So that's the confusing part. Flow is cubic feet per second and not MGD or gallons per day or whatever, which is what we're commonly used to as flow. So I would memorize the formula the way I have it, which is flow equals area times velocity. And you can do this other ways. Velocity equals area divided by flow. So flow in cubic feet per second equals area in feet squared times velocity, feet per second. So what do I have up here? I got velocity, I got a width, I got a depth. Width and depth, I can make an area. They've given me the velocities, so I have an area, I have a velocity, I can figure out the flow. And they gave me an influent BOD, but you don't need that, so who cares about that? Alright, so they gave you it in inches, and you need to find it in feet. So to find inches or feet, you have to divide the inches by 12 inches per foot. So 5 inches, So you already have 2 feet, so you don't need to do anything to that, but it's 2 feet 5 inches. So 5 inches divided by 12 inches per foot equals 0.4 feet. So 5 inches is 0.4 feet. Plus 2 feet, remember it's 2 feet 5 inches, equals 2.4 feet. So 2 foot 5 inches is 2.4 feet. So we have the width. Now the depth is 10 inches, so we have to do the exact same thing. 10 inches divided by 12 inches per foot equals 0.8 feet. So we have the width in feet and we have the depth in feet. Width times depth, or feet times feet, gives you square feet. Now I've skipped a step and I've gone ahead and added the velocity already to the formula. So feet times feet would have given you square feet, and then you would have multiplied it by the velocity. So feet times velocity equals 3.1 cubic feet per second. So 2.4 feet times 0.8 feet, square feet, times 1.6 feet per second. Feet times feet is cubic feet per second. And this is your flow in cubic feet per second. Now here's the tricky part that people get confused at, is they want it in MGD. Well, how the hell do I get it in MGD? What you need to do is you need to look on your cheat sheet where it says 1 million gallons equals 694 gallons per minute equals 1.547 cubic feet per second. And that should raise a red flag. That's what we need. So we need to go ahead and divide 3.1 cubic feet per second divided by 1.547 cubic feet per second per MGD. And remember what I said, common units when divided cancel each other out. So when I divide this by this, the only thing that's going to be left is a number and MGD. So 3.1 divided by 1.547 gives me 2 MGD. So the flow going through this channel is 2 million gallons per day if this velocity stays constant. And that's how you would figure out flow in MGD. This one is a tricky one. I say go over this question one more time if you didn't fully understand it. Just rewind the video until you learn it. Alright, time to move on. I think we're almost done. Got 2 more problems.